And if all of you had prepared sufficiently for this, you could have gone faster, but half of the class didn't prepare. But not to worry, the questions are very, very, very easy. Okay, so we can actually look at them quite quickly. Let us like last week and the week before. Remember, you must always keep in mind what we've been doing this during the lesson. Same in school also. You need to know what are the previous lessons we were taught in school, and then the concepts are brought forward. You cannot forget the past. So last 2 weeks, what do we do? The week before we did light, and the week after we did shadows, remember? And the week after today we're doing heat. Can you see? There is a progression. Okay. So based on light, we asked ourselves, what are the sources of light? So it looks like the questions that the teachers will ask me in the exams will always be, what are the sources of light? Then when you do heat, also, hey, what are the sources of heat? And therefore, you cannot confuse them. Okay, if you're confused, then you will choose the wrong answer, because they say, what's the source? You choose the source of light instead of choose source of heat, because, hello. Okay, so here, which is not a source of heat? This one, of course, light and heat, remember? So sometimes it can apply to both also. It's like lighted bulb, light and heat. A candle flame, also light and heat. What does that mean? Most of the time when there is light, there is also heat. Yes, because light can get hot. Light is a form of energy. Over time, light emits the energy called light, and then it becomes heat as well. So you usually have light and heat appearing together from the same source. Okay. Woolen sweater, is it a source of heat? Now, you wear a sweater because you feel cold. Does it mean the sweater is the one that's giving you the heat? No. Okay, it's actually preventing you from losing heat. Prevents you from losing heat only because it is a bad conductor of heat. So it doesn't conduct heat from you, bad conductor of heat. So this is a bad conductor of heat, but not a source of heat. Okay, a source of heat is like light, sun, fire. You see in front of fire, yes, you feel warmer also because that's a source of light, but you can't wear. Okay, and of course it doesn't give light and it doesn't give heat. It only prevents you from losing the heat. So this is the important definition, the way you answer if they ask you in a structured question. Why is a woolen sweater not a source of heat? It is actually a conductor of heat that prevents you from losing heat. That means you as a person, you're losing heat very quickly to the environment, especially if it's cold. Imagine you sit in an aircon room or you go to a cold country, you lose heat from your body. Your body is supposed to be 35 degrees Celsius, 36 degrees Celsius, and the temperature outside is 20 degrees. So you're going to lose heat. Travels from where? From the hot substance to the cool substance. So it will move from your body. That's why you feel so cold, because everything that's from you, your body is losing the heat to the surrounding. Whereas if you put on a wet woolen sweater or any jacket, your body does not lose as much heat because the woolen sweater sitting in front of you is preventing the heat conduction and conducting the heat away from your body. So that is the main lesson you learn from this question. Okay, so it's important, and that's why you need to know the heat sources and to be able to distinguish between heat and non-heat sources. Okay, so what are the heat sources that we have around? Like I asked you at the start of the lesson, how many of you have actually been to the 88 Tuition website to see my videos? Because on those videos, I will show you this diagram as well. Okay, so there are a lot of notes more than this. I actually picked up just 1 or 2 slides to show you here, but if you want more, okay, more notes, more slides, then you have to go to the lesson proper, which I actually conducted on the website itself. You can click in there onto the heat chapter and look at it. Okay, you can see me teaching again and again over there. Now, heat sources will include natural sources, burning fuels, electrical appliances, friction. Now, I use my hands up here. I rub my hands. I'm actually causing what? Friction. And the friction is causing heat. That's why friction can cause heat. I'm doing this one. Electrical appliances like iron, oven, all of them have heat also. due to the electricity that passes through them. So electrical energy is converted to heat energy. So that's this one. Burning fuels, you can make something burn. You can burn petrol, you can burn coal, you can burn wood, and then you create heat. That is burning fuels. And of course, natural sources, the sun, the volcano, all of them contain heat already. You don't even need to start the heat. It's already hot. Okay, so anything can produce heat. Most sources of light are also sources of heat. This is what we learned from question 1 as well. Great. Okay, so like I said, if you want to hear me talk more about this type of slides, you have to go to the website, because I'm not bringing that here again, because you do have an opportunity to go there. So you know how to do it. The sun is a primary source of heat. We all know that. Without the sun, we're going to die. Are we? Now, this is a very important question. Many people ask, what happens if the sun is shut off for a while? Do you think we will die? Do we need the heat from the sun to survive? Now, you may say in cold countries, we are surviving. Hey, the cold countries have the sun as well. It's just not as hot. But the sun's energy that provides the warmth and the heat is necessary for human survival. If not, all of us will die of cold. 1 minute you switch off the sun, do you know how cold the sun, the earth will become? It will be as cold as if you go to outer space. Of course, outer space also still receives the heat from the sun, because the sun is omnipresent in the whole outer space. Okay, but it gets colder and colder as you go out of the earth's surface. Okay, so that's the answer to the question. We cannot survive without the sun. Okay, so because it provides the heat that living things need for survival. So, and obviously, in order to survive, you need the heat from the sun. If not, you will not be able to survive. Now, another piece of note that I picked up. Okay, so you are the users of heat. Okay, there are many at home and in industries. At home, we use a lot of heat from the sun to dry our clothes, heat from the electricity. Okay, use electricity to iron, to make our cakes in the oven, and burning coals and all this. So this again is just a general picture to show you how heat can be used. Not really going to be going through this now. But this one we're going to go through in a bit of detail. What is the difference between heat and temperature? What's the difference between heat and temperature? Now, you answer me. Can you type? Those of you who are very, very itchy fingers, the fingers are like dying to type something to me. Carry on. What's the difference between heat and temperature? Firstly, it's not the same. So don't tell me it's the same. That's why primary 3, primary 4 kids get caught out. Okay. People try to say temperature is the same as heat, but no. Felix was the first person to answer. Thank you, Felix. Won't be shouting out your answer yet, but thanks, Felix. Next person, Higani. Thank you, Higani. Okay, Rushita, Celine, Jubi, everyone. Now all the answers have come in. At least 10 people have replied. Okay. But the most interesting answer is, okay, actually all of you have gotten the gist of it and are correct. 9 out of 10 of you are correct, except 1 or 2. Okay. Temperature is how cold or how hot, blah, blah, blah. Heat is, okay. So what is the misconception? Misconception number 1. Heat measured is only how hot it is. Temperature is how hot or cold it is. This is what a lot of students tend to say. If you're in primary 1, if you're in kindergarten, yes, you can say this. Okay. Why is it wrong? Temperature measures how hot or cold. Heat also can measure how hot or cold. If you don't have heat, means you have cold. What? If I say, is there heat? Yes. Is there heat? No. If there's heat, then it's hot. If there's no heat, then it's cold, isn't it? So How can you say heat only measures hot? Temperature measures hot and cold. Wrong. Okay, both have the concept of hot and cold, but the only difference is, so heat, we talk about it as an energy. Okay, we receive the heat. Temperature is we measure what is the number, how hot or how cold. Okay, so how hot, measure how hot or how cold, and we have a number, right? A number to show you. So we need, when we measure, we have a number. So that's why we say, oh, 35 degrees. Whereas heat energy, we don't say heat energy is 35 degrees. No. Okay, heat energy we calculate in joules. We say 300 joules of energy was transferred from the environment to Shiv Shankar, was transferred from the environment to Jubi, was transferred from the environment to Felix. Now, how hot has he become? Oh, his temperature has gone up by 1 degree to 39 degrees, and so on and so forth. So there is two different values, two different units. So that's what you need to take note of. So I'm going to emphasize with another color, white color here, just to see the units here and see the units here. That's how you remember the difference between heat and temperature. Always the units, the quantity is different. Okay, so you can measure how much heat that a body has by joules, and how much heat a body has by degrees Celsius or Fahrenheit or Kelvins by measuring. So that's the difference between heat and temperature. Okay, so let's go on and define using the words. Heat is a form of energy and it makes things hot. Temperature is a measurement of degree of hotness of an object. Measurement. Okay, so please take note. You will be asked many times on the differences, and you are asked to write this down. Memo. Rise this if needed. Okay, of course, if you don't memorize, then you just understand. Okay, remember, understand means this one is in joules, this one is in degrees Celsius. If I remember this way, maybe I will know, oh, this is a measure of how much energy there is. This is a measure of how hot or cold in terms of a measurement number. Okay. Okay, we continue with the differences between heat and temperature. Okay, the higher the temperature of object, the hotter it is. All this you know. Our sense of touch will let us know how hot or cold something is also. Okay, but we can't tell exactly what the temperature is, correct or not? So we can actually measure heat by our touching, but we cannot measure temperature without touching. Another way of to distinguish between heat and temperature. For those of you who say it's the same, how come? If I touch something, it's hot, right? I know hot, cold. But if I touch something, can I say what the temperature is exactly? No. So obviously there are two different things. My hand cannot measure temperature. My hand can measure heat. Measure heat, of course, not exact number, but I know if it's hot, a lot of heat, or very little heat is very cold, and so on. So we can actually talk about it in different sense of the words here. We use a thermometer to measure temperature activity. So therefore, to measure temperature, you need an instrument called a thermometer, and we have various types of thermometers. The two commons are shown here, clinical and laboratory. And this slide was also taken from my class. You can go and have a listen. So I keep saying you can go because these are the stuff your teacher teaches you in class. These are the stuff that I teach in class, in the videos, in tuition is always there. But the stuff that you did as homework needs to be continued, right? So let's continue number 2. Hey, where's number 1? Number 1 already done 20 minutes ago. Remember which was the first source of light? And we said it's a woolen sweater. That was question number 1. Now, question 2, same thing. What does that mean? Your teachers are not going to give up asking you this question. So you may say, hey, very easy. But then you are the one who are going to get it wrong in the exam. Then you'll be like, why are you so careless? Okay, so that is the situation we don't want to get into, right? So again, sun, yes, light, heat. Light, again, same thing. It's actually the same thing as earlier, but we don't have woolen sweater. I just took this question from 2 different papers and ended up having the same, similar. So what happens is you are likely to get this question in your exam too. Is that right? Because teachers love to ask this question. So if school A asks this question, school B asks this question, then school C, school D, E, F, G, which is your school, also will ask the question, and you are prepared because you attended my lesson. Yeah. So blanket is not a source of heat. Why is it not a source of heat? Now, this question, you can bring it and throw it into the section B and say, hey, Felix, hey, Aiden, hey, Suhi, I'm calling all of you guys. Hey, Branson, tell me, why is blanket not a source of heat? I give you 2 marks if you tell me. Then you'll be like, no, Mr. Ali, Dr. Ali said it's not. Then I just write. Then you don't know how to write. Why is it not a source of light? Why is it not a source of light? If you can try, you can try. I already went through it, right? Or source of heat. Why is it not a source of heat? Because does it give you heat? Is it a hot thing? You take a sweater straight away, it's very hot. No. So it does not emit heat. Rather, it what is a poor conductor. So I'm looking for this word. Those of you who write this, poor conductor of heat. Yes. When some of you wrote to me, say it does prevent you from losing heat. Yes, that's exactly what this is. So you further explain that you wear a sweater to prevent myself or yourself from losing heat. Because if you keep the heat within yourself, then you are warmer. If you keep losing the heat to the environment, then you are colder. So that's the difference, right? So prevent yourself from losing heat. You want to say some more? Yes. To where? To the external surrounding or just to the surrounding? This is called a scientific student's answer. Okay, so you can see how I explain, even though it's an MCQ question has a lot of learning to do. So you can actually apply it in other parts of the paper where section B, suddenly I can question you this same question in another part of the paper where it's not MCQ. Okay, because I asked you to explain. All right. Even though it's very easy in MCQ. Okay, Evelyn. Anybody call Evelyn here? No, only Amelia. Only Victoria. Okay, good. Now, wanted to find out if amount of water would affect the time taken for it to boil. She prepared 4 beakers. Okay. She wanted to find out. Okay, always circle this one. Find out what. Find out what. So what does she have to change? That's what she need to find out. What she need to measure. And what does she have to change? Okay, remember? She want to find out amount of water will affect the time taken for it to boil. So she need to measure the time taken to boil. She need to measure the measure. She want to see whether more water, less water, where? Amount of water. Okay, let's change color here, yellow. Why? So this one you change. So you change little water and a lot of water, and then you say, okay, how long does it take to boil? Is it longer for more water and so on? So you need little water and a lot of water. So you need to have a lot of water. Let's do. So this a lot of water, you need either with this or with this, right? So the rest of the things must be kept constant. The temperature must be kept constant. Okay, the beaker is constant, the size is constant, everything is constant. The amount of water must change. So I must change. So you see my yellow color writing on the right side. Change the amount of water. And therefore, A and D will be the most suitable answer here. Yes or no? Answer is D. Okay. This question is a little bit off the heat. Is not really about heat, it's a bit about light, right? So I actually trying to test you whether you still remember things about light. Okay, prepared 4 setups as below to find out if light is needed. So you need, again, change light. So one with light, one with no light. Then you know whether light is needed. And what do you measure? You measure whether it grows or not, right? Because germination means to grow. Okay, so which 2 setups should Ray use for his experiment? Again, you need to change only light and no light. Okay, so answer is, okay, let's see. You see the, okay, let's underline. You see this? Watered daily, Watered daily. Watered daily. Not watered, eh? This one, how come different? Okay, you must keep everything else same. You only must change the light. Okay, so the rest are all watered daily. Okay, so you can get 2 out of that. The next one, surrounding temperature 24, surrounding temperature 24, surrounding temperature 24, surrounding temperature 4. Eh? Why this guy 4? So you change suddenly. So this setup also is wrong. So it looks like A and B can work because they have 24, 24. They have watered. And they are kept in the dark and kept in the light. Eh? What's this for? This is no light. Here has light. Therefore, Ray can, well, what a name he has. His name is also something to do with light, right? Ray of light. Ray can determine whether setup A will grow or setup B will grow, and he will know whether light is needed or light is not needed. Okay, so that's why he should have setup A and B. Okay, the rest are already wrong because he's changing other things that are not supposed to change. You must keep them constant. Okay, let's get back to heat. Okay, so now, again, not many of you have not done it, so that's why I'm going to go slower on this question. Okay, because it's a long question. It is not MCQ anymore. It's going to be structured. So we're going to go long. You have 3 cups, Janice, and then Janice, just have to look at the coloring that I'm going to do. Okay, Janice put something here on the side here, and that's material Y. Okay, and then she also uses a plastic lid on the third setup, cup C. Okay, so what do you think she's trying to do? She's preventing the heat from leaving the cup. So it's going to be hotter for longer in B and C, whereas A will cool down very fast. Remember, what did she do? Keeping warm water. So it's actually warm water. So the warm water will turn cold, right? Which one will turn cold the fastest? A first. Okay, followed by, I don't know, B or C. I don't know. Now you have to go to the table to see her results. Cup B and cup C, which one cool down faster? Cup A very fast. You see, after 20 minutes, it already reached 30. But cup B, after 25 minutes, it reached 30. Cup C also after 25 minutes, it reached 30. Eh? That's not helping us. Then I still can't see who's the winner between B and C. Which one the temperature dropped faster? Okay, so we have to go to the top. From here. It went to 86. This one went to 80. So this one cooled faster. Am I right? Am I right? So I got the answer from here. If I check here, also cool faster. Because at the same time, we're looking at the same time, 10 minutes, 5 minutes, 15 minutes, and they cool faster. That means C is cooling faster. So A cools fastest first, followed by C. B is the slowest, which means B is having a very good conductor of heat. Is it good conductor or poor conductor? Poor conductor, which is the red color. So let me write it down as well. I go back to the diagram. I write down here, poor conductor. Very poor conductor compared to the lid in C. So which cup did water cool the fastest? Answer is A. For first one, answer is A. Very easy because you reach the room temperature the fastest at 20 minutes. Okay, here, this is why. The rest are still at 40 and 35. Why is it the room temperature? Because they all reach 30 and they don't go down any further. So that must be the room temperature. No more heat exchange. All right, so that's what's going to lead us to question B. Question B. Based on the result, what can you conclude about material Y? Material Y, what is material Y? Material Y is the red color we painted just now here. It is a poor conductor of heat because it loses heat the slowest. That's it. And then last one, what was the room temperature? Give a reason for your answer. Because all of them reached the final same temperature and did not go down any further. That means They reach the room temperature already. Once something reaches the room temperature, it cannot go down any further because they are all at the same temperature. Remember, heat can only flow from a hot object to a cold object. So usually a hot object is a hot water or warm water. So it loses heat to the surrounding until they are both the same temperature. So that's why the room temperature is 30 degrees. All right. Now, again, 3 materials of all different materials. So they must be poor conductor, good conductor, and so on, right? Okay. Miss Shah recorded the temperature, and now you are throwing it in a diagram. So the diagram is material A, B, C. Okay, so let's do color so that you can see. Red one is A. So red one is this one. Is it easier? Can you do this in the exam? Yes. You bring highlighters, many different color pens, and do this so that you will not mix up the curves. It's easy to mix up by, they just show you material A. I know they've already labeled it. By labeling it, you know, in the exam, you don't have color, right? It's all black and white. So they cannot do color. So they will give you material A, B, C like this. But I can use my own color. So that's my trick. So you have to use this trick as well. So material B here. Okay. And material C, maybe we can just leave it as no color. Or if I have extra color, of course I can do that. Then maybe we can do that. So just see that. You can't see, so might as well just leave it, right? So maybe might as well leave it black is better. Okay, so we carry on now. Why did the temperature of water in all the 3 containers become 28 degrees after 40 minutes? What are they talking about? Okay, they are talking about this. Here is how many degrees? 28 degrees. Why? We just covered this in the previous question, right? Because it is the room temperature. Okay, all of the things that cannot lose any more heat to the surrounding means that surrounding is that temperature. So what's that temperature? Earlier it was 30, now it's 28. Don't ever assume that it's always the temperature, room temperature that you know. Okay, my room temperature right now here is different from the room temperature right now in your room, right or wrong? Wrong. Yes, right? So everybody has a different temperature as a room temperature right now, based on the temperature of your place where you are in. You could be in another country, you could be in an air-conditioned room. So that's why your room temperature can be different. So never assume the number. Always get the answer, the room temperature from the question, from the graph, from the data. Now in the data it says 28 degrees, but they're asking why. You just say the boiling temperature lost heat to the surrounding air, which is what we've been talking about all along, and reach the room temperature 28, and hence that's why all of them go to 28, and there's no more heat to lose. You can also say in your own words that there's no more exchange of heat. Okay. Now this is a very long question, but it's still continuing. All of you can hear me, right? Okay, carry on. Okay, this is a very long question, but it's still the same question. Now the same person, Miss Shah. Okay, now it's very boring to always say Celine, Janice, Branson is all your friends and students' names. So now we actually mix it up with saying Miss Shah. So it's like a science teacher or can be somebody's mother. Okay, just mix it up a bit. Miss Shah would like to choose a suitable material for making a cooler bag to keep her cold drinks cool for a longer period of time. She's obviously maybe going to exercise. She wants a cool drink after that. So which material should she put her drink in and bring it with her? Imagine it's a water bottle. Okay, which material do you think she should choose to keep her cool drinks? Remember, cool drinks. That means it shouldn't lose heat. It should stay cold. Okay, remember, she pour drink that is cold. If the heat can enter, what will happen? Your cold drink will become warmer and warmer. So therefore, you need a material that keeps the heat out. So you need poor conductor. So you need the poorest conductor. So the poorest conductor will gain heat slowly, right? As slow as possible. So which one gains heat slowly? Now go back to the graph. Okay, and then we need the color again. We forgot the color. This one drops very fast. Then the second color. This one drops not so fast. Takes longer to drop. The last one is very good. C. It takes very long for it to drop. That means it loses heat very slowly. So here, the answer is, based on the graph from the data, C loses heat slowest. Okay, therefore it's a poor conductor. And that is going to allow it to gain heat slowly also because it's a poor conductor. So C is a poor conductor. So that's why she will choose C. Okay, C is the poorest conductor of heat, so it will lose heat slower than the materials A and B. And so Miss Shah should choose material C, not the other two, to keep her drink cold. Okay, so let's take a breather, stretch your arms. Okay, I've been talking a lot, you all didn't participate at all. So now you all are experts on heat, so you're going to participate more in the second part. Okay. So while I'm taking a break, let's have a discussion. Some of you asked me, hey, teacher, if I color my question paper just like you said, you color in red and in yellow, wouldn't my question paper be messy? Will your teacher bother it's messy or whether you get the correct answer? Teacher going to mark the answer or going to mark the coloring? Teacher going to mark the question or teacher going to mark the answer? Okay, if the coloring is going to help your answer, okay, don't worry about the messy coloring, just color as much as you want. Okay, no problem. No teacher is going to say it's going to be messy. And if you are in primary 5 and 6, there's going to be more coloring needed because the questions are going to be more confusing, and then you need more colors to actually make the question look easier for you. You understand what I'm saying? So in primary 3, primary 4, maybe you don't need to color to see things. But primary 5, primary 6, it becomes more complicated. Like just now we saw some questions. And then you need to put in colors to actually help you see. So don't worry. And the best part, in PSLE, you get question paper and you get answer paper. Do you know that you take the question paper back and the answer paper you give to the teacher? So is it okay if you color your question paper? Yes or no? Yes, because it's your own paper. Okay, it doesn't matter. The teacher doesn't want to see your question paper. The teacher wants to see only your answer paper. So your answer paper will have very clean answers, nothing messy. And your question paper, you can scribble, you can do anything you want. That's why earlier when I did the MCQ, I can go and cancel, right? Remember, I do the A, the B, option B is wrong. I cancel anyhow, it's okay. Okay, unless you are submitting the question paper in primary 3, primary 4, I understand. Don't make it too messy also sometimes. Okay, if you want to use colors, do it neatly then. Okay, you don't need to be messy, right? All right. Okay, let's carry on. We have a few more questions. A cup of this set of questions, right, is more challenging because it is to do with heat flow. Okay. Okay, before we carry on, some also ask me, hey, what if my teacher don't allow me to bring colors? I don't see a problem. How many of you teachers tell you cannot bring a highlighter to school? How many teachers tell you cannot bring a green pen to school? No, right? I don't think so. If it's going to help, yeah, you can. So some people say, what if my teacher don't allow me? Of course they will allow you. Okay, as long if they don't allow you, then you bring it just for the exam. Then in the exam they won't say anything, because in the exam you can bring anything you want, except stuff that they tell you specifically you can't. Like for example, for math you cannot bring a calculator. Then you cannot use calculator. But in P6 there are questions that you can use a calculator and so on. You wait for that. Okay, you wait till you go P6. Okay, question 1. It's about heat flow. So you need to know which one loses heat, which one is gaining heat. Remember, let's go back to the sweater that you're wearing. Okay, who's losing heat? You, right? The person, your body is the one that is losing heat. Who is gaining heat? If you are losing, somebody else is gaining. Okay, the environment is gaining because you're in a cold country. It's very cold. It's 20 degrees. That's why you even think of wearing a sweater. Okay, how about you? Okay, what am I doing? Don't know how to draw a person. Okay, let me draw a simple person. You see, very bad, Mr. Ali. Do not draw. Okay, I want to draw nicer, but in the end, okay. So you are losing heat because your temperature is always constant. Your body temperature will never change wherever you go, whichever world you go in. Your body temperature is still 35, 36. Okay, not 356, 36, 37 maybe. And then you look at the picture. You see the outside temperature is 20. That's why you're losing heat, because whoever is hotter will lose heat to the colder. So you are losing heat. So this is what you must. So the outside is gaining heat. Outside surrounding is gaining heat. So this is what we mean by who's gaining heat, who's losing heat. So in this case, we have a hot cup of coffee, and then there's a cup and there's a cold water. So the hot cup of coffee is the hot one. So he must be the one losing heat to the colder one, because this one is colder. The cup is colder, right? Before you pour your hot coffee in, the cup will always be colder. Only after a while, the cup gets hot. Remember that? All of you have drunk coffee or tea before now. No, your parents have. You pour the hot tea inside a cup. The cup is actually cool, right? You pick it up from your kitchen, you pour it. So what happens? It gains heat from the coffee. So that's why you have to write gain. And then here you have to write loss. You see the difference? Okay, so coffee will lose the heat and cup will gain the heat. Now, so obviously the answer is going to be A, because that's the only one with the two circles. Then what about the cold water? It also gain, because it's cold. What? Cold will gain the heat from the cup and the coffee. Therefore, answer is A. Okay, so you look through, you will know which one is the correct answer by splitting the parts one by one and always determining for yourself which one is the hottest one, the coffee. So the first one is the hottest one. So you will lose the heat from there first, always the hottest one. Now you have two experiments of ice. One is the block, one is the cube, which is cut from the same block into three pieces. They tell you it's the same size, okay? Equal amount of water. This is important. They are not different amount of water. So if this is 50 ml of water, this is also 50 ml of water, no difference. So you can't say there's less ice or more ice. There's same amount of ice, but only different. What is this? Different what? Do you know this word? Why? What is surface area? The area that is exposed to the environment. Remember, you're losing heat to the environment. So if you're touching the environment more, you lose more heat. So which one touching the environment more? See this guy. One surface, two surface, touching three surface, four surface, five surface. So if I actually calculate, it's actually how many surfaces? If each cube has 6 surfaces, 6 times 3 equals to 18 surfaces touching the environment. Whereas here, I only have 6 surfaces. 6 faces in that sense, right? 6 faces is in contact with the environment, with the outside air, right? The other one has 18 surfaces. Therefore, it can lose heat faster. So let's look at how it loses heat faster. See this. Hey, look at that. Can you see? All surfaces, double quick work, 18 times faster. But this one is so slow because it's only having 6 surfaces. So surface area, greater exposed surface area is the answer. But we have A and B with that answer. So which one do we choose? So I can delete these two, right? This is what I mean. I can be messy a bit, no problem. So only B and D says ice block has the greatest exposed surface area, or the ice cube has the greatest exposed surface area. So this one, is it the ice cubes or the ice block? So you make your choice. Ice cubes, not the ice block. Here again, many of us can just see the wrong answer in a split second. You saw greater surface area. Oh, B. Okay, put B. Then you got it wrong. Or some of you saw B, this B, and you put it here B, like this. Also wrong. You can be careless. Please, under exam pressure, and those of you who are really careless all the time, please take note. Sometimes you choose this B and you write as B, and then you got it wrong. Okay, so please make sure you do not choose the wrong answer. Things can be confusing when you are trying to be what? Accurate in your answer. Sometimes you got to be really careful. So the answer is from here, not from there. All right. Ice cream, very favorite topic of mine, right? Of all of us. I love ice cream. You love ice cream. I have not known a single person in this world who doesn't like ice cream. Maybe those who don't like sweets don't like ice cream. Now you can eat non-sweet ice cream. Okay. You know, the trend is to eat what? Frozen yogurt, right? Then that's healthy. And still people love it. That whole sensation of something frozen is always nice. So people who don't like ice cream because it's too sweet still eat frozen yogurt and so on. And that became a trend because it's healthier. So how many of you eat frozen yogurt? Me. How many of you eat more ice cream than yogurt? Okay. You should change from ice cream to yogurt if you want to be healthier. But it's okay to treat yourself to ice cream once in a while. Okay. Let's see. Hey, nowadays a lot of people are selling ice cream to each other. Do you know that? Because it's a circuit breaker, right? And all of us are stuck at home, cannot go and buy ice cream, and a lot of ice cream shops are closed. Especially the ice cream vending man who's always standing around Orchard Road selling ice cream in a biscuit or in a bread is also missing. He cannot do his business. So what happened? People are buying ice cream from the online shops, and then you get ice cream at home. And I receive ice cream from my family as well. People send it to me, say, "Hey, Ali, go have this. This is your treat." Okay, they just order and they put my address and send it to me. So who wants the same thing? Put your address and then I send ice cream to you. Of course you want. Me. Joshua, you're the first one. Okay, Joshua. Now, but all of you have to participate more. Next week, okay? Let's see if you all do your homework and then I ask you the question and then maybe I can send you ice cream. Nowadays, it's easy to send prizes and presents, but nobody want to participate now. I don't understand. Look at, I gave you all a challenge. You didn't do the challenge. If you had given me the challenge, share it with me on my WhatsApp. I would have given you a prize, a present, like an ice cream to your house. I said, let's do shadows. Send me shadows experiments to me. How many of you attended last week's lesson? I said, do some shadows and WhatsApp to me. Not many people did. So you didn't do your work, you don't deserve ice cream. Sorry, yeah. Okay. So you want to be rewarded, please do the work that I've been telling you. Okay. Ice cream for the deserved person will land in your house. Trust me. If you do, if I'm get happy with you. Okay. Okay. So again, ice cream melted quickly and metal bowl became cold. So what happened? What happened? Ice cream gained heat, right? This is what we're going to talk about all the way till we finish. And lost heat. Because it became cold. If something become cold, is losing the heat. If something become hot, is gaining the heat. So can gain heat. So I underline. So this is wrong. This is wrong. See how fast I quickly eliminate. Make sure you can do messy stuff like this so that my answers are very clear cut for me. This one, lost heat, right? So gain is wrong. Loss is correct. Loss is correct. Gain is wrong. So which one? I haven't deleted yet. Only C. So can you see how easy it is? Okay. To find the answer if I start deleting. Okay. Again, same thing. So that's why you can go fast. Now, what's the answer for this? This is how you can do, right? While I write down, please tell me the answer in the chat. Pot. Pot is hot or cold. Cold first, but then you receive the heat from the fire. So a bit. So where is the heat transfer from? Originally from the fire. Then pass to the pot. Then pass to the, what is inside? Soup. Let's just call it soup. So therefore, which one of the following explains this? Explain what? The pot became hotter. Okay, I underline explain what. The fire gains heat, from the pot. No. The pot gains heat. Yes. The fire lost heat. No. The plastic handle lost heat. We don't need to talk about plastic handle at all because we're talking about only the pot. The plastic handle lost heat is totally out of this picture. So we got only A, B, C, and A and C are out. So B is the answer. Okay, this slightly faster because you really understand the concept. You can actually go through it on your own. Those of you who have not tried it. The questions will be on the website as usual still. So I know you have not tried it. You can download it and try it at your own free time. But now we still have to continue and go through the questions and finish it up. And to those of you who think it's 4 o'clock, I want to go, hey, what more important things do you have in life to do during this circuit breaker? A lot of things. I thought we are all bored at home. So we must just stay here for another 5 minutes, right? Because I have challenge coming up at the end of this lesson, just like last week. Last week's challenge, nobody took up my challenge, no ice cream. Actually, I wanted to give popular vouchers, like Toys R Us vouchers, some more Smiggle vouchers, and then ask you, hey, you want a prize? Do you want Smiggle voucher? You want popular voucher? Or you want Toys R Us voucher? I'll ask you, if you're the winner. How much? That depends on how well you answer my questions, okay? Nobody took up challenge, nobody win. Okay, next week, let's see who take up the challenge and win something. But then the prize have one more option now, okay? I'm going to have Toys R Us voucher, you want Smiggle voucher, you want popular voucher, or you want ice cream. Okay, and next week I'll ask. So I welcome you to join next week's lesson. It's going to be fun because I'm going to ask the winner what you want as your prize. Okay. First, do the challenge when you have the time. Okay, let's see how many of you actually end up doing the challenge. Okay, and then next week is already the last week of holiday, before school reopens. So please take the opportunity to do as much live lesson as possible. After that, school starts to become very, very, very tired. And then, of course, we still continue the lessons for you as much as possible, and we are still available on AT Tuition. Let's carry on. We're going to finish. The metal spoon became hotter after a while. Now, which of the following explain this? Again, explain what? Remember, I always say explain what? You must go and ask me explain what? Explain why the metal spoon became hotter. Not anything else, only why the metal spoon became hotter. Not the fire, not the pot, but the metal spoon. So I got to highlight the metal spoon here. Can you see? I highlight. See, these are all the important things colors can do, and also highlight. Of course, you can just use pencil also. Now I will go into the question. The pot lost heat to the hot soup. Pot? Why are we talking about pot? Why? We don't want to talk about pot, right? We want to talk about spoon. 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 Okay, that's why A is definitely out. You understand? Now, the rest talk about spoon. The spoon lost heat or gained heat? Remember, the question above says the metal spoon became hotter. So it became hotter means it did not gain or lose. Gain, right? So if you gain heat, where is it gain? Gain, gain. Eh? So we are left with C and D. The hot soup gain heat from the spoon, or the spoon gain heat from the hot soup? Obvious, right? Which one got hot first? The soup first, then the spoon. So the spoon gain heat from the hot soup. Okay, this one is straightforward. Now makes it a lot more different. Interesting. Primary 6 level now. We have two objects are at different temperature. What are they? 50 degrees and 25 degrees. And what's the outside temperature? Or the dish, the liquid that is losing the also 25 degrees. So which one will lose the heat? This one will lose the heat. Right? So this is P. This is Q. Will Q lose the heat? No. Why? Because they are equal. So they will not lose any heat, not gain any heat. That's the effective. Which of the following shows the heat flow? E will lose heat to Q. This one, right? Okay. So P will lose heat to the liquid and also Q. So P, Q will lose heat to, no, not this. How many got the answer? Very easy, but difficult because the options are confusing. Okay. P loses heat to Q only. No, it loses to W as well. P gains heat. No, it does not gain at all. P loses heat to Q and W. Yes. P loses heat to P and W loses heat to P. No. Something wrong. Okay. So whatever we discussed is C. Okay, you need to know the direction. P is losing heat to W and P is also losing heat to Q and not at the other way around, and that's it. All right. Haslina conducted an experiment, okay, and she covered the same cup of water with 4 different materials that will keep her cup from what? Losing heat or gaining heat. At the start, it is cold water. So look here. At the start, it is cold water. All of them. What's going to happen? They are going to gain the heat. Imagine you have a cold water. You just took up orange juice or juice, peel fresh juice or marigold juice from your fridge and you put it on the table. What happened? Okay, immediately, what happened? It will get warmer. But it will get warmer if you don't do anything, if you don't cover it, or if you don't keep it in a styrofoam box, it will get warmer. So you want to keep it cooler, you put it in a styrofoam box. So that's what she's trying to do. So which one became warmest first? Oh, A. So this one is a poor conductor of heat. A is lousy because it became warm so fast. Poor conductor. And which one was keeping the temperature low for long? The 5. So this one, this 5 is a best conductor of heat, good conductor. Which one? Which is good conductor? B. What about poor conductor? A. Porous. So can we put them in a ascending or descending order? Arrange the material based on the heat conductivity, starting from the, this one allows students also make mistake. Although they know the order, they mix up the order. Starting from, start from what? Starting from the poorest heat conductor. So you go up there, poorest heat conductor is A. Okay. Then the best heat conductor is, poorest conductor is A. Best conductor. Wrong, right? Now, I wrote wrongly here. Now, how many of you picked up that? This one, I have to interchange, okay? This is a poor conductor because it doesn't allow heat to pass. This is a good conductor because it allows heat to pass, okay? You understand the difference? A poor conductor does not allow heat to pass. Therefore, B is the poorest conductor. So all of you got wrong. All of you. Okay? You're not reading it, you're just following me blindly. I just immediately switch this. Can you see? Now B is the poorest conductor because it does not allow any heat to pass through, therefore keeping her drink cold for the longest. So it's B first, followed by D, C, and A. Okay, this is the answer. Poorest conductor is B. All right. Now Haslina wants to hold a cup filled with hot tea without burning her hand. So you choose the poorest conductor, otherwise you will burn your hand. Like imagine you use metal, it's a good conductor, you will burn your hand. So use poorest conductor. So which one is it? Poorest conductor is B. So she will use B because B is the poorest conductor and the heat will gain. So you must explain your answer. A lot of you did not explain. Okay. Now draw an arrow to show the direction of heat flow where? Between the water and the air in the container, not the container, but air. Okay. So air in the container is here and the water is here. So we need to do that. Okay. Draw an arrow to show direction of heat. That's it. Okay. Okay, Hansen conducted experiment, find out which material is better conductor of heat. He set up the experiment as shown below. Again, by looking at how quickly the temperature drops. This one drop faster, or this one drop faster. Setup B, drop faster. Is it? No, slower. This one drop faster. If drop slower means this is a poor conductor of heat. This is a good conductor of heat. You have to write all these down. If not, you're going to not have some tools to answer the question. Okay. So material W and material X, we know already. So this is W. Let's do another color. This is W, this is X. Okay, let's go. So part A, they just ask you, based on the experiment, put a tick, okay, next to each variable to show if it should be changed, kept the same, or measure. What are you measuring? Okay, go back to the experiment description. He's finding out, remember, find out, always find out what? Which material is better conductor of heat. So he needs to change the material. Change material. Measure temperature of water, right? That's what he's measuring, am I right? In the table. So what does he measure? Temperature of water. What does he change? Material of beaker. That's it. These two are the most important things. You only always have two things. When you find out for an experiment, you only always have two things. One is you change, one is you measure. One is you change, one is you measure. Always two things. We already identified. What about the rest? The rest keep the same. That's it. So if you identify the two things, one is to change, one is to measure, the other always the same. And that's how you get your answer quickly. Okay. In order to get those ticks, you have to read the question to see what is this person, whether it's Hanson, Tom, or Harry, or Sally, or whatever name is trying to find what, do what as experiment. Which material will have an effect on the temperature of water. Now remember, which, earlier we did germination, say which one has light, well, he's trying to find out whether light will affect germination or not. So he needs to change light. Put one in light, one in no light. So that is change. What do you measure? You measure whether the plant grows or not. So you always have two things, and then the rest keep the same. Okay, that's the way you do fair experiment. So in which setup will the temperature of water increase faster? That means increase faster means must be poor conductor of heat. Which one is a poor conductor of heat? Because increase slow means good conductor. Poor conductor of heat. Which one is poor conductor? Go back. Earlier we saw, right? Go back. Go back. Go back here. Poor conductor is X, right? So X is the poor conductor because it also, so this was X, this was W, and the temperature actually falls slower, which means it's a poor conductor of heat. Again, you're mixing up. Good conductor of heat. Which one, in which setup will the temperature of water increase faster? Okay, increase faster or reduce faster is the same. Both are good conductors. So again, I'm making the same error. So it's very, very easy to make errors. So please take note and check your answers all the time. Okay, so it must be a good conductor of heat. So is it W or X? So answer is setup A, where it is W. Okay. You need to tell me which one I have to write. This one dropping slowly, so this is poor conductor. This one is good conductor. Okay, so good conductor of heat. So we'll absorb heat faster because material is a better conductor of heat. Okay, take note, here the temperature is dropping. Here they're asking you will increase faster. You need to make a relation that both is the same. Okay, whether the temperature goes up fast or reduce fast is both the same. That means the conductor is good conductor of heat, which is example like metal. Okay. Finally, Ali wanted to keep his coffee warm for longer time. Again, same thing as just now, Misha and all of them wanted to choose a material where you want to keep coffee warm for a longer time. So you choose a poor conductor of heat. Which one is a poor conductor of heat? Setup B. Setup B is X. Am I right? So which material should she choose? X. Which, since material X is a poor conductor of heat, the coffee will lose heat slower. You can see how we moved from simple question to a medium to a very tough. It gets tougher and tougher, okay? Because you need to be able to realize that good conductors, not only temperatures fall fast, they also rise fast. Poor conductors, temperatures will fall slowly and also rise slowly, okay? Because the heat exchange, the main important thing is the heat exchange is slow or fast based on the conductivity. Okay, so you check the heat exchange. All right. Do we have time for this question? Not really, but you can try it on your own because I want to check out of this lesson. I don't want to take so long, too much time. But we do have questions that have asked you to draw the graph as well. So it's very easy to plot a graph. Just put down the numbers. Okay, do it on your own later because a lot of you didn't try it yet. So you can just put number 1, number 2, number 3. So your graph should look something like that. Okay, but I'm not going to show you the answer. You are going to try it. Okay, together with the challenges because I know I'm going to give you the challenges. So these are the answers which I'm not showing you, but I want you to do challenges. This challenge number 1, this challenge number 2, and this challenge number 3. All of them are MCQ. So I'm making it easy this week. MCQ. Let's see if you can answer the challenges and get all 3 correct, and then we look at for a winner next week. If all of you are winners, then I have to draw lots. Who's going to get the ice cream? Okay, so these questions will be uploaded back to the website later today or tomorrow. Check tomorrow is better. Download it and answer these questions we discussed next week at the start of the lesson, just like we did this week with the challenges of last week's. You understand? Yeah. Okay. Well done, and see you soon. Have a happy final week of circuit breaker. All right. See you. Bye-bye.